Hi, my name's Brenda Hartman. I'm a master's student in public health at California State University, Fresno. I'm here to talk to you today about water.
The southern Sierra Nevada mountain range lies east of the San Joaquin Valley and supplies the valley and foothill residents with water for crops and human use. This mountain range was formed by the movement of the Pacific tectonic plate against the North American tectonic plate, forming granite, a porous rock which is formed by slowly cooling magma, and over the years, as the soft layers of the metamorphic and sedimentary rock are eroded away, leaves large outcroppings of granite that we know as El Capitan and Half Dome in Yosemite National Park. This unique combination of rock spans the entire length of the state of California. And as the snowpack melts, water fills the rivers and lakes and the underground water space. Water gets trapped in the cracks and the fractures of the granite. I'm standing here today at the northern inlet of Bass Lake, just outside of Oakhurst, California, one of the hundreds of water reservoirs that have been created in order to supply the San Joaquin Valley with the water it so desperately needs. As you can plainly see, there is human-induced pollution in the water from recreational boats and human activity. But what I wanted to discuss with you today was the naturally occurring contaminants that endanger us all who drink this water. Naturally occurring particulates that are held inside of the rock include arsenic and uranium. And for the residents of the foothills of the Sierra Nevada, these contaminants are a serious public health concern because residents must rely on either private well water or well water supplied by the municipal water company. Arsenic and uranium are naturally occurring constituents in the Earth's crust all over the world. While acute exposure to arsenic can be fatal, chronic exposure can also cause serious health effects. Approximately 70% of the ingested arsenic is excreted through the kidneys or converted by the liver and excreted through the body through its urine. Arsenic has neurotoxic effects, and chronic exposure is associated with many types of cancer, including skin cancer, lung, liver, bladder, kidney, and prostate cancer. A recent Poisson regression analysis tested the relationship between historically high arsenic concentrations in U.S. drinking water and the incidence of lung and bladder cancer. The findings indicated a positive and significant association, but stronger studies will need to be conducted. Arsenic levels that range from 50 to 100 parts per billion are found in the drinking water in many areas of the United States. It was in 1942 that the U.S. Public Health Service set the interim drinking water standard to 50 parts per billion, but in 1962 they identified 10 parts per billion as the goal. This was due to the studies that proved that arsenic concentrations were a significant risk factor for cancer. The International Agency for Research on Cancer identifies arsenic as a Group 1 carcinogen and states that there is no safe level of arsenic in water. While humans are exposed to small amounts of natural radioactivity every day, most of the radioactivity in groundwater comes from the decay of the naturally occurring isotopes of uranium and thorium in the rock of the aquifers. A report that was published by the U.S. Geological Survey and the California State Water Resources Control Board in 2014 examined 25,000 square miles of the fractured bedrock aquifers in the Sierra Nevada mountain range. Radioactive constituents occurred at high levels in 8% of the primary aquifer system and at moderate levels in about 20%. Uranium, radon-222, and gross alpha particle activities were the constituents that most frequently occurred at high and moderate levels. In an interview with Sarge Green from the California Water Institute at Fresno State, he explained that Oakhurst is within the scope of all three major rock classifications: granite, metamorphic, and sedimentary. So several water quality issues coexist in that area, including uranium, arsenic, and nitrates on the primary drinking water standard list, and iron and manganese on the secondary list. Only the nitrates can be attributed to either natural or human-induced occurrences, and all the others are natural from the dissolution out of the rock. This complexity and the fact that the Sierra water is in fractures and thin sedimentary deposits rather than an aquifer system makes predicting the location and conditions of water in the foothills and the Sierras very difficult. It's largely luck in many instances to have both quantity and excellent water quality. As far as human knowledge knows, anything that has a nuclear composition is not good to humans. Uranium exposure can affect the human body system. It can depreciate the functions of vital organs such as the heart, brain, liver, and kidneys. The health effects are caused by its chemical properties as a heavy metal and not by radiation. But eating or breathing very high levels of uranium can cause acute kidney failure and even death. The maximum containment level of uranium is determined by the California Safe Drinking Water Act at 20 pci per liter. Since 1990, over 23 public supply wells have been shut down in the California Central Valley due to elevated uranium levels. But let's go back to Oakhurst, where we started, 13 miles from Yosemite and 40 miles from Fresno. It's a small foothill community where most residents have their own private wells, but private wells are not regulated, and homeowners may never test their water because arsenic and uranium are clear, odorless, and tasteless. Some homeowners have installed point-of-service filter systems for their tap water, or larger systems, if they can afford it, for bathing and irrigating their gardens. The people who live in the main part of town rely on Hillview Water Company, a California Public Utilities Commission regulated water system. They've been supplying water to approximately 1,000 homes and businesses since 1990. In August of 2012, the California Department of Public Health filed court proceedings against the Hillview Water Company for violating the Safe Water Drinking Act. Their report documents the average arsenic concentrations of their tanks at 24 to 25 micrograms per liter. And the uranium concentrations averaged for the same time period approximately 35 to 39.9 picocuries. As a resident of Oakhurst, every quarter I receive in the mail a statement from the Hillview Water Company notifying me of the current uranium levels and the current arsenic levels of the water supply. The Hillview Water Company has been working to correct the problem with the 13 online wells. Due to Prop 84 funds that were set aside in 2007, they received a $5 million grant to improve the water treatment facility. In October of 2017, building began on the new treatment plant from water remediation technology. It'll be operational in March 2018 and will remove the uranium from the water, collect and transport it for repurposing. Investigation into the treatment system led me to email the company. My question? What happens to the arsenic? In spite of government regulation and $5 million grant, I foresee no change in the arsenic levels of our drinking water in the near future. This leaves the poor and the disadvantaged at a greater risk of health problems from chronic arsenic ingestion. Even if you can afford to purchase water by the gallon, we still wash, bathe, and swim in it.